let's learn how to find derivatives by the definition. The given function is 5x plus 3 squared of x. We are asked not to use any shortcuts, which we actually learn in the next chapter. If you do know the shortcuts, then it's handy to use it just to check the answer. The derivative of this function will be 5 plus 3 times 1/2 x to the negative 1/2. And I will not be explaining this right now since you'll be learning it later. This is only handy to check the answer. So on the test, if you are asked to use a derivative definition, but you use the shortcut instead, you will not receive any points, unfortunately. Let's start working on this problem via the definition. First, you need to know the definition, obviously. So the derivative of the function will be a limit, and that's how I memorize it as a student. There's a fraction. I remember there is an h in the denominator, and h goes to 0, so we have division by 0, but because h never reaches 0, it's actually not too bad. In the numerator, we have a new function, which is called x plus h inside of the f, minus the old function f of x. And this is a definition of the derivative. I like to teach these types of problems through steps. Step 1, let's find the new function f of x plus h. F of x plus h will be when I need to use a new input instead of the old input. Old input was x. New input is x plus h. That means I need to find all the x's in the function and substitute them with a new input. In this case, it's x plus h. So it's kind of like find and replace. 5 was multiplied by x. Now it will be multiplied by x plus h. Remember the new input. Plus 3 square root, and it used to be square root of old input x. Now it will be x plus h, like so. And actually we're done in this step. So let me highlight what I did. I changed all the inputs that used to be x to be x plus h. The second step is to calculate this whole numerator of the fraction in the definition of the derivative. F x plus h minus f of x equals 2. Let's write down. Let's immediately distribute 5, and we're going to have 5x plus 5h plus 3. Remember, you cannot distribute the square root if there is a sum or difference inside of the square root. Put brackets or parentheses. I like to use brackets. Negative sign, it comes in the formula. Open brackets or parentheses and write down the original function. The original function is 5x plus 3 square root of x. Now you know why I distributed 5, because I want to get rid of the 5x that repeats twice, but once with a negative sign. So the simplified version will be 5h plus 3 square root of x plus h minus 3 square root of x, like so. You cannot simplify more right now, because I will remind you again, and it is a very important reminder, the square root of x plus h is not a square root of x plus the square root of h. You can only distribute the, let's use it a and b, distribute the square root if you have product or quotients. Square root of a and square root of b. But not sums and differences. The third step is to divide by h. That will complete calculation of this whole fraction. And the last step will be to actually substitute 0 to find the limit. Substituting 0 into h, not everywhere. So I need to divide by 0. Let me remind you the formula. Fx plus h minus f of x divided by h will be, and I will have 5h plus 3x plus h minus 3, I forgot to say square root, divided by h. And now let's see what I'm going to do here. I will break this one fraction to 3 fractions. it's going to be 5h over h. So it's just 5 plus, actually I will break it into two fractions. Originally I wanted to break it into 3, and then I checked it, and it is easier to do it with 2. X plus h inside of the square root, and x inside of the square root, and divided by h. And this is the result of the almost last step. Again, did you see what I did? I broke it into two fractions. 5h over h gave me 5. And then these fractions stayed. So the last step is to calculate the limit. What kind of limit? H is the variable in this limit, not x. 5 plus 3 squared of x plus h minus 3 squared of x over h. Well, we have two limits here. Limit of 5 is 5. So we solved this limit. The second limit, let me write it down again, even though it's a little bit annoying to do it every time. Minus 3 squared of x over h. And h shrinks to 0. This is what I have here. So I know it's going to be 5 plus the answer for the limit. How do we solve limits like these? Do you remember? You should. It was two first chapters of the Calculus 1 class. Maybe you remember the phrase multiply by the conjugate. If you see a square root in the numerator, especially the difference of square roots, that should give you a hint to multiply and to divide by the conjugate. And the conjugate means I will recreate those two square roots, with coefficients in front of them, but with the opposite sign. Since it's what's negative, now it's going to be positive. So plus in the middle. But because I cannot just multiply by something and say that that is legal to do, I have to divide by that term as well. Like so. So multiply by the conjugate. Multiply by the conjugate. Review conjugate. Review homework of limits. Somewhere at the very beginning. It's the chapter called Calculate Limits Algebraically. Why did we do that? Because we're going to use the formula, which hopefully you remember really well. A minus b multiplied by a plus b is a squared minus b squared. So this is exactly what is happening in the numerator, where a is 3 square root of x plus h, and b is 3 square root of x. And we like this because when we square each term, the square root will go away. Thus, we will have limit. Don't forget to write limit every time. I know you love doing that. Then it's going to be 3 squared x plus h with no square root. I decided to skip the step with a square root and a square on top of it. Minus 3 squared times x, and there's also no square root. That, let me explain again, happened because the whole numerator is the formula called difference of squares. And this is the formula of difference of squares. The denominator now looks a little bit worse, but that is not actually true. You will see it. You will see why in a second. Maybe 2 seconds or like 5 seconds, because it's not the end of the problem. So I want to factor out, I want to get rid of the h. The goal is to get rid of this h that makes denominator to be 0, and I don't want that. So I would like to kind of have numerator with h being factored out. Then I can get rid of it. Let's see if it's possible. The numerator will be, let's distribute 9 times x and 9 times h. 9x plus 9h minus 9x. Yay! 9x and minus 9x gives you 0. And now I have h isolated, standing by itself, ready to be cancelled out with the h in the denominator. Let's copy all the other terms. Do you know why we can cancel out h? Remember, we cannot cancel out whatever is 0. We cannot divide by 0. but h is not 0. Limiting position means that h is getting closer and closer to 0, but will never reach it, or might never reach it. Thus, I can write down 9h and h, 3 square root of x plus h plus 3. Did you finish the problem faster than me? Try and see who will finish it faster. H gets cancelled out, exactly how we wanted it. Now we have a constant at the top, and that means we are ready to substitute h as 0 in the limit, because it's a limiting position. Let me highlight again. H that goes to 0 will give us 9 in the numerator, 3 square root of x plus 0 plus 3 square root of x. The answer is 5 plus 9, 3 square root of x plus 3 square root of x gives you 6 square root of x, right? And that can be simplified as 3/2 over square root of x, or x to the negative 1/2. And that is the final answer, which matches with whatever I had using power rule, which we'll learn in the next chapters. Here is what I have here. 5 plus 3 over 2, and x to the negative 1/2 can be written as 1 over square root of x. So it matches the same result. And that's how you can check it on the exam. Use the definition of the limit, but feel free to use the knowledge you have from other chapters. But you only need to use definition of the limit if you're asked to do that. Now let's finish answering all the questions. I will not write down the derivative in this box. You can do it by yourself. But what is the question about the domain? Domain of the original function. Domain means we need to be careful and exclude all the bad inputs for x. X inside of the square root cannot be negative. Thus, x have to be positive. Is square root of 0 exist? Yes, so 0 is fine too. They told us that we need to use interval notation. Thus, that is just a cute way to write down as x greater or equal to 0, but professionally, you need to write down that x belongs to 0 to plus infinity. We do not include infinities because you can never reach it. But do we include 0? In this case, we do, because square root of 0 exists. And I don't think you need to write down x belongs. That is read as x belongs to the interval in those boxes in your homework problem. Let's see if something is different with f prime. F prime is over here. Is domain different for this function? The x is still on the side of the square, so it should not be non-negative. But now it ends up to be in the denominator, so it should not be 0. Thus, 0 have to be excluded for the derivative of the function. X belongs to the new interval. 0 is not included, so use parentheses but not brackets, to plus infinity. X used to be greater or equal to 0 for the original function, but now it's strictly greater than 0 for the new function, which is the derivative of the original function. I know it was a pretty long problem, so try to be patient and work a little bit more on other homework problems using the definition of the derivative. Definitely remember the formula. And don't forget to drink some water.